Hello friends, welcome to our channel. Let's have a look at problem 3439, reschedule meetings for maximum free time 1. So basically we are given a time duration, right, from 0 to infinite time, and we are given a ordered events which are non-overlapping by start time and end time. So we can reschedule at most key meetings by moving their start time while maintaining the same duration to maximize the longest continuous period of free time during the event. So here, one important assumption is that the relative order of all the meetings should stay the same and they should remain non-overlapping. So we want to return the maximum amount of free time after rearranging the meetings. This note is also some consistency assumption. So here, if you look at the three examples, example 3 is very special because here k is 2, but the meetings cover the interval 0, 1, 1, 2, and up to 4, 5. So 5 is the ending time, therefore there's no free time, the output is 0. And in example 1 and example 2, the k are both 1. In some sense, the three examples that do not cover the most generic case, right? For example, we have some free time, but k is greater than 1, right? So here the event time is in this bound, and the start time and end time, at least their length is bounded by 10 to the power 5. So this basically tells us the problem size. Then from the last two items, we know that the start time and end time are ordered, right? So with that said, actually we can digest the method we're going to use. Essentially for this problem, we can solve it in O of n time complexity. So here we just need to do a linear scan, right? So here actually it's very good to look at the hints. So here if you have a key meetings, if you consider the left and the right, there will be k plus 1 gaps. So you could move all meetings to the start of the sequence and then to get the maximum free time, right? So this is actually very easy to get, right? So you know the overall duration of the k plus 1 gaps, then you minus the sum of the durations of the key meetings, you get the free time. So that's what we are going to use. But here, let me first use example 1 to demonstrate the idea. So here, if you look at example 1 at I equals 0, so then the two gaps begins from 0 and end at 3. So the duration is 1. So overall, you can move 1, 2 to 0, 1. Then the free time will be 3 minus 0. 3 minus 0 will be the total duration of the two gaps. Then minus this one. This is the duration of the meeting, so you get 2. And if you look at I equals 1, you are going to look at the meeting start from 3 and ending at 5. So the gap will from 2 and then ending at 5, right? So you can move 3, 5 to 2, 4, for example. Then the gap will be 5 minus 2. That's the gap, and the total duration including two gaps. And then minus 5 minus 3. So this is the duration of the meeting. So you get 1. So overall, the largest gap is 2. That's the return for this example. So overall, I feel that these three examples does not cover the general case. For example, k is greater than 1, and also we have free time. But you know, this example should be sufficient for us to do the coding. Let me first get the length of start time. Actually, this is also the end time because these two have the same length. This is for convenience. Then I can first get the duration of the first k minus 1 meetings, right? This is actually very simple. So we get end time I minus start time I. So here for I in range k minus 1. Notice that in this problem, we assume k is greater than or equal to 1. So this is always good. So now what we want to do, let me initialize a result variable. This result variable the final state is what we want to return. And then we are going to scan the to list. So here we can do it for I in range. So because we have already summed the duration for the k-1, first k-1 meeting, so we're going to start from k-1 and then ending at n-1, right? So then first we need to know, we get this piece of information, like here 0 and 3, right? So we call it previous. The previous will be 0 if I is less than or equal to k-1, right? Otherwise, it will be the previous end time, right? So it will be end time I minus k, right? So in order to get this end, we need I is greater than or equal to k, right? That's why here, if I is less than or equal to k-1, we're going to get 0, right? So in other words, the starting, right? So after will be event time. If I plus 1 equals n, in other words, the last event we're going to consider. Otherwise, it will be the start time of the I plus 1 event, right? So the after minus previous will correspond to here, right? Then we just need to sum the duration. But notice that if we scan the current meeting, so the duration actually, if so the duration first we add the current duration to the this variable. That will be end time at index I minus start time at index I, right? And then if I is greater than or equal to k, right, then we need to drop the earliest one. That is duration is going to minus this end time at I minus k minus start time at I minus k. So now the current duration state will be the total duration of the key meetings in consideration. Then the free time, so the free time will be, let me introduce this extra variable. So this will be after minus previous, so minus the duration. So what we want to find is the max, right? So the previous state of the result, and then the current free time we can get. Then we just need to return this result state. That's actually the full coding. Let me quickly run it. Yeah, it passes all the cases. Now let's submit to check. Yeah, it passes all the cases. So here, let me see. If you like, actually, you can comment out these 2 lines and replace it by 1 line. That's the max result after minus previous minus duration. This should be also good. So with that said, I guess that's about it for the current coding. So overall, actually, we use the hint 1. Actually, that's the major point. So with that said, that's it. Thank you for watching.